In this section, we will explore the graphs of sine of x and cosine of x and see what they look like in the regular xy plane, as opposed to thinking about those in terms of the unit circle. So our objectives will be to graph y equals sine of x, y equals cosine of x, and then of course their translations, which for trig functions are going to have particular names that we're going to run into of amplitude, period, and phase shift. So first of all, what we're going to run into is the fact that the trig functions are periodic, meaning every time you go around the unit circle, the values start repeating themselves. So if you look at the sine of t and you add any multiple, any whole number, integer multiple of 2 pi to t, you're going to get the same value. So the sine of t plus 2n pi for any integer n is going to be the same as the sine of t. Same thing for cosine, because by adding multiples of 2 pi, you're just going around the circle to the same spot. So any function that this happens for, where the values start repeating themselves, is called periodic. The trig functions happen to be periodic, and sine and cosine have period of 2 pi. That smallest measurement that it takes for the function to start repeating itself is called the period. So sine of t and cosine of t had period 2 pi. And then the particular graphs, if we start looking point by point, and we think about how y on the unit circle defines sine and x on the unit circle define cosine, we see that these values are always going to be trapped between, or oscillate between, -1 and 1, and take on all values in between, which is going to create graphs that look like waves. They call them the sine waves and the cosine waves. Here was a picture that one of the textbooks I was using one time had that shows particular values matching up. So here's one complete period of the sine graph. If you start at the point 1, 0 on the unit circle, where the rotation is 0, the sine value is 0. And then when you rotate around all the way around to pi over 2, you get to a height of 1. So at pi over 2, the tick mark's a little off here. Pi over 2 would be here, pi would be here. It maxes out at 1, and then it goes back to 0 when you get to pi, and then at 3 pi over 2, it's at -1, and then it comes back up to 0, and of course you fill in values in between. Here's an animated version with Geogebra. I have a slider where I can run t from 0 to 360 degrees, and I chose to use degrees here instead of radians, although it's very common to have our variable be radians. And the point A is going to be, if you look at the properties, it's the point t sine of t, so it'll map out the sine curve. And the point B is cosine of t sine of t. And there you see one complete period of sine. As our point rotates around the circle 360 degrees, we're mapping out the point with the same angle and the y value. We get the sine curve. So to draw one complete period of the sine graph, there's a pretty systematic way to do it. You can use these 5 points and you get the really nice points on the graph. You get the x-intercepts and the max and the min. The sine graph is 0 at 0, pi, and 2 pi, because the y-coordinate on the unit circle is 0 when you're at those points. And it maxes out at pi over 2 with a height of 1 and has a minimum at 3 pi over 2 of -1. So you can always plot those 3 points. I say you got one hump going up, one going down on one complete period of sine. And I'm going to fill in here. You, of course, could fill that in with your pencil, but let's do f of x equals sine of x. And we see the sine graph. And, of course, it is periodic. We usually just graph one complete period of sine. But if we zoom out, we'll see that it oscillates infinitely, repeating that pattern over and over of one up, one going down, one going up, one going down.